So the primary goal of this video is to review slope and y-intercept in a linear equation, specifically as it relates to connecting how a table of points is related to a graph of a line and how those two are related to the equation of a line y equals mx plus b, and how that's related to a situation such as a word problem. Other uses include explaining how to interpret a slope and y-intercept in a situation such as a word problem. So actually all of these are related to the primary goal of the video. So hopefully it will help you with those things. All right, so we're going to do that by looking at a few word problems. Okay, so we're going to start with from the ground up. That's what we're going to do. So for number one, first of all, the directions. So for every single one of these problems, we are going to draw a picture of the situation. We are then also going to fill in the missing parts of the table of points. We're going to graph the line that contains those table of points, and then we're going to find the equation of the line. So that's going to hopefully connect the situation, which is A, with the table of points, which is B, the graph, which is C, and the equation of the line, which is D. So we're trying to make a connection between all the four of those things so that we can analyze. And if I give you the equation of a line, you should be able to tell me what the table of points are. If I give you the graph of a line, you should be able to give me what the points are, and et cetera, et cetera. If I give you any one of those four things, you should be able to give me the other three. All right, so here's situation number one. Frida the frog hops over every other lily pad down a line of them in a pond. Find the equation that shows the number of lily pads she's gotten to by hop X. All right, so first we're going to show what Frida the frog is doing. And Frida the frog is going to be green. To green. All right, so she's actually on land. And then here's the water. We're going to have lily pads down the line. So she hops on every other one. So there's one lily pad, but she does not go on. And then she goes on the second one, because it says every other lily pad. So by hop number one, she's on lily pad number 2. She skips 3. By hop 2, she goes on lily pad number 4. And by hop 3, she gets to lily pad number 6. Okay. All right, so that's my picture of the situation. B, fill in the missing points in the table. So here, X stands for the number of hops, and Y is the lily pad that Frida has reached. And it actually says in the table that by hop number 2, she's on lily pad 4. So I can check that. By hop number 2, she's on lily pad 4. And that's what my picture says. So I'm going to come back here now. And by hop number 1, she was on lily pad number 2. You can see that right there. By hop 0, she had not gone any lily pads because she was still on the ground. And hop number 4, I did not get to draw, but the table shows lily pad number 8, excuse me. So you should be able to see the pattern that she goes every other one. So she skips to 2, 4, 6, 8, 10. So we're counting by 2s. So you should be able to fill in that point there by following the pattern that she keeps increasing the number of the lily pad by 2. So she goes plus 2, plus 2, plus 2, plus 2. Every time. All right, C, graph the line that contains the table of points. So we're going to graph those points 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. Now 5, 10, you can't really graph accurately, so you don't have to. Entire grid, so that's what I'm going to do. Your graph of your line should be better than mine because it's very hard to graph on a computer for me. So I expect your line to be straight and that you used a ruler. All right. So that's the graph of Frida the frog's hops. So X is the number of hops and Y is the lily pad number. So we can see that at hop number 2, for example, she's on lily pad number 4 according to this graph. according to that point right there. All right. Find the equation of the line. All right. So the equation has to relate y and x. So there must be a way for me to find out what lily pad she's in compared to what hop she's on. So if she's on hop number 0, according to this, she is, when she's at hop number 0, she's gone 0 lily pads. At hop number 1, she's gone 2 lily pads. At hop number 2, she's gone 4 lily pads. So how do I get from the x number to the y number? Well, it's doubling. So whatever the hop number is, it's times 2. And that matches this right here because this is the amount she increases by. So she's going up by 2 pads for every 1 hop. That plus these plus 2s that are steady and never change, the amount of change, that rate of change, that's telling you that for every 1 hop, she's going up 2 lily pads. So 2 lily pads per hop. Okay, so that means for every 1 hop, she's gone 2 more. So when x is 1, I've gone twice that many lily pads. When the number of hops x is 2, I've gone twice that many lily pads. So you always take the rate of change and put it in front of x because that tells you how much you changed for every 1 x. So if I were to relate this to the equation of a line, because this is review for you. So if this is review for you, you've already seen y equals mx before. And that m stands for the slope or the rate of change. And the slope is the number of the rate of change. Okay. Because the rate of change tells you how much the y changes per every 1 x. So this is it. In this graph, the y changes 2 lily pads for every 1 hop. Okay. So the rate of change equals the amount the y changes. So in this case, number of the lily pad per every 1 x, which is the number of hops. All right. So that's going to be the equation for Frida the frog. Let's try another example. See if that one was not your favorite. Let's see if we can make it clearer with another example. So we're going to skip the water bug one because that's similar to Frida the frog, and we're going to try the ladybug one. Okay. All right. So ladybug situation. A ladybug is currently 1 centimeter above the ground and crawling up a tree. It climbs 3 centimeters per second. A, draw a picture of the situation. Well, this is going to be helped by my table because at the table it says that at 0 seconds, the ladybug is 1 centimeter above the ground, which matches what it says right here. The ladybug is currently 1 centimeter above the ground, meaning at the start, we started at 1 centimeter. That's what it's saying, okay? And it's going up 3 centimeters for every 1 second. So I'm going to draw the ground. Here's my little grass. And then here's my tree. Oh, we're going to need more colors right there. It's a bit brown right there. So here's my tree. Oh. And then my ladybug. So my ladybug is currently 1 centimeter, so we're going to make that right here. Again, math teacher, not an artist, but there's my ladybug. All right. So he's 1 centimeter, and he's going to go 3 every 1 second. So he's going to go 3, then another 3, then another 3. So there's my picture. And he started at 1. So if he started at 1 and he's going up by 3 more in 1 second, for every 1 second, that's going to be at 4. 1 plus 3 is 4. At 2 seconds, we're going to add 4 plus 3. So 4 plus 3 is 7. We're going to add 7 plus 3 to find out where he gets next. That's going to be 10. 10 plus 3, that's going to be 13. And 13 plus 3, it's going to be 16. So that's going to be how far he gets in 5 seconds. All right, so that was filling in the table. C is going to be to graph that line. So I'm going to shrink that a little bit so you can fit that table there. 0, 1, 1, 4, 2, 7, 3, 10 is roughly here, and there's really not going to be any way I can do the other lines, so I'm not going to try. Suppose that at 0 seconds, the ladybug is at 1. At 1 second, the ladybug is at 4. At 2 seconds, the ladybug is at 7. And at 3 seconds, the ladybug is off the graph at 10. Right up there. And we'll erase all that. Okay. Find the equation that relates the ladybug's height to the number of seconds that have passed. All right, so this problem is going to have we want to know how high up that ladybug is. So y is the height of the ladybug. Y is the height. So y is the height of the ladybug. And we need to find an equation for the ladybug height, given if I give you any number x for a number of seconds that have passed, right? So think about it as, well, the ladybug's height to start with is 1. So the start amount is 1. So we're going to start with 1. That's how much the ladybug started at. And then she's going to keep going up by 3 more every 1 second. So she's going to go up by 3 in 1 second, right? So I have to add 3 one time in 1 second. So at 1 second, the ladybug's height is going to be 1. So y is the height. And if I make it at 1 second, if I'm making like an XY table, for example, at 1 second, the ladybug has gone 1 that it already started with, plus another 3. I believe it was centimeters, another 3 centimeters. So the height is going to be at 4. At 2 seconds, the ladybug still started at 1, but it went up by 3 centimeters twice because 2 seconds have passed. So that's going to be 3 centimeters times 2. 6 plus 1 is 7. So the height is at 7. At 3 seconds, see if you can fill that out yourself. Using this, see if you can fill out what the equation work is going to be. All right, so it should be that you've started at 1 centimeter above the ground when no seconds have passed, plus another 3 centimeters times 3 seconds, because the ladybug has been moving for 3 seconds. So 3 times 3 is 9, plus 1 is 10. So that means that the ladybug, if I now keep going, and I'm not going to tell you the seconds anymore, it's going to be x now. Well, the height always starts at 1. So I always have that 1 no matter how many seconds have passed, because I've gone 1 even when 0 seconds have passed. Plus, it goes an extra 3 centimeters every second. And if I don't know how many seconds there are, I'm just going to have to put, something called a variable whenever you don't know the number. So if I don't know how many seconds have passed, I just put an x for that. So the equation is going to be y equals 1 plus 3x. And that comes because that 1 is the start value. So it's always going to be y equals the start value plus how much it changed by for every 1 second x. Well, what is that how much it changed by number? The how much it changed by number is called slope, and we use m to stand for slope. So it's m times x. So m stands for slope. And then that start value, what do we call start value? Well, the start value is when x is 0. Well, when x is 0, that's always going to be at the y-axis, because when that's by definition what's going on. So the start value is called the y-intercept, and we use the letter b to stand for it. So the equation is going to be always going to be the start value, which we let b stand for the start value of the y-intercept, plus mx. And the way that that's usually written in math books, it's actually y equals mx plus b, not b plus mx. All right, so that should look familiar to you. So that's where the equation y equals mx plus b is. The b is the y-intercept, or the start amount. And the m is the slope. Okay. All right.